Prove that in a rhombus, the sum of the squares on the sides is equal to the sum of the squares on the diagonals. You may assume that the diagonals of a rhombus are perpendicular and that every rhombus is a parallelogram. We have to set everything else up ourselves. So let's start by drawing out a rhombus, A, B, C, D, and we're going to join A to C, that's one of the diagonals drawn in, and we're going to join B to D, that's another diagonal drawn in, and we have our little right angle symbol here to show that the diagonals meet at right angles where they are perpendicular to each other. So we let ABCD be a rhombus whose diagonals intersect at X. So this is point X, the point of intersection. We are told that AC is perpendicular to BD, and that as ABCD is a parallelogram, AX equals CX, so AX equals CX, and BX equals DX, so BX equals DX. By the definition of a rhombus, AB equals BC, which equals CD, which equals DA. So AB equals BC, which equals CD, which equals DA. Because with a rhombus, all the sides are the same length. Thus, the sum of the squares on the sides of the rhombus, AB squared plus BC squared plus CD squared plus DA squared will all give us 4AB squared, because each of these are equal to the length of AB, and there's 4 of them, so we can just rewrite it as 4AB squared. Also, the sum of the squares on the diagonals, AC squared plus BD squared, so AC squared plus BD squared, can be rewritten as 2AX squared plus 2BX squared. So if we have a look at AC, it's from the top to the bottom, but it's the same thing as 2AX because AX and CX are equal to each other. So we can rewrite AC as 2 times AX because it gives us the same length. So AC squared becomes 2AX squared. And likewise, BD is equal to 2 times BX. So this is BD, and we know that BX is equal to XD. So BD can be rewritten as 2 times BX. It's the same length. So therefore, BD squared is going to be 2BX squared. So 2 squared is 4. And AX squared just stays as AX squared, and 2 squared is 4, and BX squared just stays as BX squared. So we get 4AX squared plus 4BX squared. Now consider the right angle triangle ABX. So ABX, so it's written out here separately, ABX. By Pythagoras' theorem, and Pythagoras' theorem is c squared equals a squared plus b squared, where c squared is the hypotenuse and the a and the b are the other two sides. So if we have a right angle triangle ABX, we're going to label AB as c, the hypotenuse, BX as a, and AX as b. So we're going to have c squared, which is going to be BA squared, or AB squared, is equal to a squared, which is BX squared, plus b squared, which is AX squared. So we have AB squared equals AX squared plus BX squared. Thus, on multiplying by 4, so if we multiply across by 4, the AB squared becomes 4AB squared, the AX squared becomes 4AX squared, and the BX squared becomes 4BX squared. So remember, the question asked us to prove that in a rhombus the sum of the squares on the sides is equal to the sum of the squares on the diagonals. So we started off by working out the sum of the squares on the sides, and we got 4ab squared. And then we worked out the sum of the squares on the diagonals, and we got 4ax squared plus 4bx squared. And then using Pythagoras' theorem and multiplying across by 4, we worked out that 4ab squared is equal to 4ax squared plus 4bx squared. So we have let the sum of the squares on the sides, which is 4ab squared, be equal to the sum of the squares on the diagonals, which is 4ax squared plus 4bx squared. So we have 4ab squared is equal to 4ax squared plus 4bx squared. And so the sum of the squares on the sides of the rhombus is equal to the sum of the squares on its diagonals.